Instructors, MOOC platform developers, experimental researchers, and data mining or machine learning researchers in education often wonder, how can we keep improving an online course even after it is deployed to students? How can we develop, identify, and deliver better versions of course content over time? How can we personalize the learning experience of students based on their characteristics? When new ideas for improvement arise, how can we systematically test these ideas out and incorporate them into real world online courses quickly and efficiently? Our answer is the MOOClet Framework, a novel software architecture that enables experimentation, machine learning and human driven improvement, and personalization by augmenting front end components of real world educational interfaces with back end APIs and databases. We designed these APIs and databases such that course content can be flexibly adapted by instructors and researchers as they explore new ideas, data, analysis techniques, and algorithms. We refer to any interface component augmented with this back-end architecture as a MOOClet. The overarching goal of the MOOClet framework is to make educational interfaces future-proofed for a broad range of not yet specified research involving manual and automated methods for experimentation, data-driven improvement, and personalization. To operationalize this overarching goal, we define 8 design requirements, derive the MOOClet framework architecture and web service implementation that addresses these requirements, and describe 4 use cases that exemplify how and where the framework is most useful. The design requirements focus on enabling iterative experimentation through A/B comparisons, resource improvement using data from past learners, and personalization using data on specific individuals or subgroups of learners. They also emphasize the importance of easy modification of course content, data, and algorithms at any point in time to allow flexibility with the range of future iterative research, even before it is known exactly which ideas will be tested, what data available are useful, and which algorithms are most effective in the real world. The MOOClet framework architecture consists of 3 key software abstractions: the version set for flexible addition of versions of course content, the policy set for many ways to choose which versions to present, and the learner data store for curating student characteristics for personalization. The front-end learner interface and the back-end admin panel draw on these abstractions and communicate with each other via API calls. The key conceptual insight is an equivalence in implementing software for 3 different functions. A randomized experiment presents 2 or more alternative versions with equal probability. Enhancement or improvement is achieved by using data to modify that probability based on human analysis or machine learning algorithms. And personalization is achieved by delivering resources conditional on a feature of a learner, for example, their prior knowledge or their performance on past problems. The use cases not only illustrate how the framework functions, but also demonstrate how the framework enables real-world research. For example, in use case 3, we describe how the functionalities of Axis, which is an existing system for generating and experimenting with learner-sourced explanations, can be re-implemented and extended using our framework. To understand what can be achieved with the framework, let's consider the following usage scenario. If an online math instructor on edX wishes to identify the best way to explain the concept of standard deviation to her students, she can have a MOOClet implemented which delivers an explanation of standard deviation on a particular lesson page. The motivation for the instructor to use the MOOClet is that she anticipates that future research could be conducted to improve the explanation, although there is not yet a formulated plan for what ideas to test, and in its current form the MOOClet simply delivers the single original explanation. The framework leaves the door open for future improvement. Students' questions and comments on the discussion forum later suggest an alternative explanation for standard deviation. This is added to the MOOClet version set, and the probability of assigning the 2 explanations is manually set to 90% original and 10% new at first, perhaps out of caution, but with no red flags raised, it is later changed to 50% original and 50% new. The instructor collaborates with the researcher to evaluate the 2 explanations using quantitative metrics such as ratings of explanations and accuracy in solving related quiz questions, as well as qualitative feedback such as students' comments and questions on the explanations. The instructor comes up with a 3rd explanation based on this data, and after another experiment with equal probabilities set to each of the 3 explanations, decides that it is better than the others and adopts it for the foreseeable future by setting the probability to 0% for the first 2 explanations and 100% for the third. The MOOClet enables this cycle of iterative experimentation and data-driven improvement to be repeated any time in the coming years as new ideas arise or data emerges about how to better explain. The MOOClet also enables automation of data-driven improvement. For example, logging code can be used to send MOOClet metrics like student ratings of explanations. The next time explanations are proposed, to avoid manual analysis, the course team could use a built-in, widely used multi-armed bandit algorithm for adaptive experimentation to automatically analyze explanation ratings and change the experience for future students. Finally, the MOOClet also enables personalization. As a more diverse range of students take the course, survey data suggests that changing the vocabulary and examples of an explanation could make it more helpful to students from different countries. The MOOClet enables the course team to work with researchers to either run an experiment to test the impact of alternative phrasings on different subgroups of students, or write if-then rules that give certain explanations to students from certain countries, or apply a range of algorithms for personalization and recommendation to optimize delivery of different course content based on a more complex learner profile. The MOOClet Framework provides an ecosystem that transforms online course components into collaborative microlabs where instructors, experimental researchers, and data mining or machine learning researchers can engage in perpetual cycles of experimentation, improvement, and personalization. Such multidisciplinary collaborations can help improve student outcomes in tandem with conducting real-world research. MOOC platform owners and developers can help instructional teams glean insights on ways to improve their courses. Experimental researchers can go from a single experiment to a sequence of iterative studies and use data more quickly. Data mining and machine learning researchers can use MOOClets as a test bed for applying and evaluating algorithms for adaptive experimentation, with the rare capacity to choose actions and get access to outcomes and contextual or state data in real time. To learn more, visit mooclet.org or reach out to usingmooklets@googlegroups.com if you would like to use the framework in your course.